There we go. All right, and nobody has asked any questions. All right, Sarah, help us out here. By the way, I feel like I'm getting sick, so I've got my little medicine ball from Starbucks. But sorry if I keep clearing my throat. Okay. Oh, yeah, the worksheet. You know what? Hang on. I do have the worksheet. Hold on just a second. I didn't bring it with me, though. I'll be right back. Okay. So glad I have the worksheet. Okay, so number one on the worksheet. So this is an investment problem. And so I'm going to start by label this worksheet number one. So I'm going to get organized and put my information in a chart. And I'm going to write a very pretty equation up at the top. Principal times rate times time equals interest. All right, so let me read this out loud to you. It says Jim borrowed some money at 13% interest and some money at 16% interest. So why don't we go ahead and put those percentages in. So the rate is the percent, but we don't want to write 13%. We want to write the decimal equivalent of that. So 0.13, and then the 16% is 0.16. It says the amount at 16% was $200 more than twice the amount borrowed at 13%. So for the principal for 13%, we want to call that X. And now for the amount at 16%, it says $200 more than twice the amount borrowed at 13%. So twice that amount is 2X and then plus 200. All right, so there's my principal. Because they talk about annual interest, then my T is just 1. And then once I have 3 boxes, I can multiply straight across to get the the fourth. So I get 0.13x for that. And then for this one, 0.16, the quantity, 200x plus 2x plus 200. And then there's one piece of information I haven't used yet. It said if he had to pay a total of $234.50 in annual interest. Okay, so there's that word annual again. Okay, so my equation is 0.13 plus 0.16, the quantity, 2x plus 200, and that equals 234.50. Okay, so I'm going to distribute my 0.16, so I get 0.13x plus 0.32x plus, I want to make sure I don't make any careless mistakes, so I'm going to use my calculator and do 200 times 0.16, and I get plus 32. And that equals 234.50. All right, my 0.13 plus my 0.32 is 0.45, so I have 0.45x equals 202.50. And then when I divide that 202.5 divided by 0.45, I get 450. So not only did my chart help get me organized, it also allowed me to find my equation without really having to think about anything. And then lastly, now that I know that my X is 450, I can come back to my chart and say, oh, that's right. That was the amount of money that he borrowed, $450 at 13%, because I want to give a nice complete answer. Okay, and then I'm going to take that 450, multiply it by 2, and add 200, and that gives me $1,100. Oops. $1,100 at 16%. And so these two answers in red are my final answers. Okay, there we go. Okay, Sarah also asked for number 7 on the quiz. All right, let's switch to red. So quiz number 7. Oh wait, number 7. I'm sorry, it's not on the quiz. It's number 7 on the worksheet. Okay, worksheet number 7. Okay, Mary can do a job in 8 hours that Joan needs 10 hours to do. How long will it take them if they do the job? How long will it take them to do the job if they work together? Okay, there are different ways of solving these work problems. This is the way I do it, and I just think it's very easy. I'm just not sure how Mrs. Dunkel or Mr. McKee teach it. So if any of you are from their classes and you're like, that's not how he taught me, there are different ways of going about it. Okay, so I like to put time alone on the outside because when I write rate times time equals work, this T in my formula right here stands for time together. Okay, so in the formula it's time together, but they typically talk about how long it takes somebody to do the job alone, or else they ask for how long did it take them to do the job alone. Okay, so here it says Mary can do a job. Let's write an M for Mary and a J for Joan. So Mary can do a job in 8 hours, so that's her time alone, and Joan needs 10 hours to do the same job, so that's her time alone. And once you know what the time alone is, then the rate, that's their work rate, is 1 over 8, or the reciprocal of 8, and then 1 over 10. Okay, so those are their work rates. Then they ask us how long will it take them to do the job if they work together. So that is implying that they're both going to work the same amount of time. So once I have 2 boxes on my chart, I can find the third. And I like to write this product here for W as 1 fraction. I'll show you why I prefer that. This is x over 8 because the 1 times x is x for the numerator and then 8 is in the denominator. Some of you have been writing 1/8 x, but you put your x as if it's in the denominator, and that's so wrong. You mean 1/8 times x, okay? But you're putting your x so low, it looks like it's in the denominator, and then you're probably going to treat it as if it is in the denominator. So I would suggest you not write 1/8 x. Write it the way I just did, x over 8. All right, so then this one is x over 10. Okay, and then we want to get always 100% of the job done. So all of these work problems, if you're doing it the way I've shown you, you're going to set your equation equal to 1. All right, so my equation is x over 8 plus x over 10 equals 1. And then I have an equation with fractions. And so I want to, first thing, get rid of the denominators. So I'm going to multiply everything through by 40. And at this point, some of you will remember to multiply each fraction by 40, and then you'll completely leave the 1 alone. So I'm going to suggest that you guys go like this to remind yourself that every single term on both sides, each term needs to be multiplied by the 40. Okay, so for that first term, the 8 cancels with the 40 to give me 5, so then I get 5x. The 10 in the second term cancels with the 40 to give me 4, so I get plus 4x equals, and if you put 1 right here, you're going to get it wrong. It's 40 times 1, so I get 40. So 9x equals 40. I divide both sides by 9. So 40 over 9 is 4. That's 36. So then, whoops, 4 and 4/9. And I don't even remember what the heck x stood for. So I look back at my problem, my organized chart, and I go, oh, that's right. X was the amount of time together. And since their time alone was in hours, this also is hours. Okay, so that's how long it would take them to work together. If you wanted to change it to hours and minutes, of course, it's 4 full hours. And then I would take in my calculator 4 divided by 9 and multiply it by 60, since there are 60 minutes in an hour. And so this is approximately, I'm going to put my little squiggly equal sign down here, approximately 27 minutes. Okay, so if you changed your 4 and 4/9 hours to hours and minutes, it's approximately 4 hours, 27 minutes. The 4 and 4/9 is exact, so I actually prefer that answer. Okay, there you go, Sarah. All right, Sarah says there was a question on working together on the quiz. Can I go over that as well? All right, let's see which one that was. Yes, it's number 6 on the quiz. All right, let's switch to Pretty Blue. Quiz number 6. All right, it says if Emily and Susan work together, as soon as you know it's a work problem, I would make a chart. I would write up at the top, rate times time equals work. And that's so easy to remember because rate times time also equals distance. That's pretty easy. And then I'm going to put time alone on the outside. Okay, this problem involves Emily and Susan, so I'm going to label that with an E and an S. Okay, it says if Emily and Susan work together, they can complete a project in 6 hours. Well, that's their time together, and that's what this T right here in the formula stands for. So they told me 6 hours if they work together. Okay, working alone, it takes Emily 10 hours to complete the same project. So Emily, 10 hours. It says, how long will it take Susan to complete the project if she's working alone? So I'm going to call her time alone on the outside, X. And now I know the rate for Emily is 1/10, or the reciprocal of 10. And so Susan's rate is 1 over X. Then once I have 2 boxes, I multiply to get the third. 1/10 times 6 is 6/10, but I'm going to simplify that to 3/5. And then I get 6 over X when I multiply those two. And as I just did in the last example, we want to set their work, the sum of their work together to equal 1 because we want them to get 100% of their job done. And 100% equals the decimal equivalent 1. All right, to get rid of my denominators, I want to multiply by 5x. Don't forget, every single term on both sides of the equal sign have to get multiplied by 5x. So my first term, the 5's are going to cancel, and so I get 3x. Second term, my x's are going to cancel, so I get plus 30. And then the 1 on the other side has to get multiplied by 5x, and so we get 5x. All right, I'm going to subtract 3x from both sides, so I get 2x on the right side equals 30, and so x equals 15. Okay, and then I come back up here, switch to red, and I say, oh, that's right, x is the amount of time it takes Susan working alone. So 15 hours was the final answer. Okay. Now I think you should double check all of your answers, not with the equation, but rather with the words. All right. So we already know how much work Emily gets done because we figured it out. We knew her work rate based on her time alone. Then we multiplied by 6 and we got 3/5. So she got 3/5 of the job done. So doesn't that mean Susan has to get 2/5 of the job done? Well, let's see if our answer of 15 hours makes her get that much done. So right here I have my 6 over x, so 6 over 15. 3 goes into both of those. 3 goes into 6 twice, and 3 goes into 15 5 times. And look at that. The 3/5 of the job that Emily got done plus the 2/5 that Susan got done equals the whole job, 5/5, or 1. Okay, so that tells me that I did the problem right. Okay, Sarah is also asking for the mixture problem from the quiz. All right, let me find that one. Actually, there were 2 mixture problems. There was the acidic solution problem, and then there was the coffee mixture problem. So Sarah, can you tell me if you wanted coffee or the acidic solution? All right, she asked for coffee. Okay, so the coffee one is number 2. All right, I'm going to go, let's try to make purple. Here we go. All right, so quiz number 2. All right, it says Starbucks makes a coffee blend. Oh, a little Starbucks advertising. There we go. Okay, Starbucks makes a coffee blend. By the way, we're going to mix 2 things together and get a third thing. So when I do my rows, I'm going to go like this and like this, but on that bottom one, I'm going to try to make that nice and bold. Okay, and what I'm trying to simulate is when you guys started learning how to add, you would add vertically. You would write, for instance, 3 plus 4 equals 7. So that line right there to show like this equals this when I add two things, that's what I'm doing with this thick uh, horizontal line. Okay, so I'm going to write quantity up at the top. You guys have a tendency to want to say amount, but I don't know. I feel like the word amount is so generic. Um, so quantity, I'm saying like how much coffee are we going to buy or mix together? Okay, so quantity times the price per pound. I could write unit price, but I'm going to just write the word price. And then I'm going to say that that's going to equal the total price, and I'm just going to put a dollar sign. Okay, total dollars. All right, so let's read this and get organized. So it says Starbucks makes a coffee blend that costs $10.20 per pound. Let me read the whole thing so I can figure out whether that first thing that they told me is one of the two things I'm mixing together, or is it what I'm going to end up with. So it says the blend is made from Colombian coffee, which costs $12.75 per pound, and Tanzanian coffee that costs $8.50 per pound. To make 8 pounds of, to make 10 pounds of the blend, how much of each type of coffee should be used? All right, so they told me there's Colombian, there's Tanzanian. I'm just going to put a C and a T for that. Those are the two we're mixing together to get this blend. So I'm going to write out the word blend. That's what we're going to end up with. Okay, so let me go back. Notice the first sentence said Starbucks makes a coffee blend that costs, here's the price, $10.20 per pound. Okay, and the original quiz said $10.25, but then the numbers didn't turn out nicely. So I'm changing it to $10.20. We get nice, neat integers. I think that was a typo. Anyway, $10.20 per pound. Okay, but you've got to realize that that blend is what you end up with. So that's why it goes on the third row. All right, so back to the problem. It says the blend is made from Colombian coffee that I labeled with a C, and it costs $12.75 per pound. And with Tanzanian coffee, that's $8.50 per pound. All right, so we know their cost per pound. Now it says to make 10 pounds of the blend. So down here at the bottom, they're telling me that we're going to end up with 10 pounds. So it seems like they didn't give you enough information because they didn't say anything about the quantity of Colombian or Tanzanian coffee. So that's where you have to think. I'm going to call one of them X. It doesn't matter which one. But the other one you cannot call X, because if you do call it X, you're assuming that both have the same amount, and then I could just answer it. It'd be 5 pounds of each. Well, that's not the case. So if I have a total of 10 pounds, doesn't that mean I have 10 minus X for my Tanzanian? And to double check that, I'm going to add X plus 10 minus X. Well, my X's cancel, and I get a total of 10. So then I know I'm right. Okay, so now I'm going to multiply straight across. I get 12.75x. Here I get 850, the quantity 10 minus x. And when I multiply 10 times $10.20, I get 102. And then here in red, I'm going to circle. There's my equation, and I don't even need to think at all. It just appears. So 1275x plus 850, the quantity, 10 minus x equals 102. All right, so now I'm going to distribute my 850. So I get 85 minus 850x equals 102. Let's use our calculator to not make careless mistakes. 1275 minus 850. And I get 425x, 4.25x, and then 102 minus 85, and I get 17. So then that's 17 divided by 4.25 is 4. Okay, and right now I don't even remember what x stood for, so that's where your chart comes in handy again. 4 was the quantity of Colombian coffee, so I'm going to say 4 pounds of Colombian coffee. And then I plug in my 4 to the 10 minus x, and I get 6 pounds of Tanzanian coffee. And those are my two answers. Okay, now can I check this? Absolutely, and I'm not going to use my formula. I'm going to just think about the problem. Well, if I have 4 pounds of coffee that costs $12.75 per pound, that would be $51. I'm just going to put my dollars over here in red to the right. Okay, if I have 6 pounds of 8.50, $8.50 per coffee, that would also be $51, and that adds up to $102, which is 10 times $10.20. So then I know that I'm correct. All right, there we go. All right, so let's go back. Okay, Emma is asking for number 14 on the worksheet. All right, I like that purple. So worksheet number 14. All right. I think that many of you probably don't think that drawing a picture is something that you would even entertain doing, and you really should consider it. So I think this problem is a little bit tricky until you understand it. Okay, so I'm going to read it and I'm going to kind of draw a picture that's not very sophisticated, but it's going to make this so much easier. So it says, at noon, a train leaves Bridgeton heading east at 90 miles per hour to Cogsville, which is 450 miles away. Then it says at 12:15 p.m., a train leaves Cogsville heading west to Bridgeton at 100 miles per hour. At what time will they pass each other? Okay, so I'm going to put a point right here and the letter B for Bridgeton. Okay, and that train is heading east, and it tells me it's going 90 miles per hour. Okay, then I'm going to put a point over here for Cogsville, and that train leaves a little bit later, but it's heading west toward Bridgeton, and it's going 100 miles per hour. So let me put over here that this one leaves at 12:15 p.m. This one leaves at noon. All right. By the way, I'm going to call the train that's going from B east towards C, I'm going to call that train 1. Okay, and then the one that leaves from C and goes towards B, I'm going to call train 2. You don't have to, but this will just make it easier for us to identify them. Okay, the one piece of information I haven't used or written yet is that those two towns are 450 miles apart, and that is key in this problem. Okay, this of course is a distance problem, so I'm going to make my boxes. I'm going to write my formula at the top. Rate times time equals distance. Okay, for train 1 compared to train 2, train 1 is going 90 miles per hour. I already put my units up there, so I'll just put the numbers for now. The second train, train 2, is going 100 miles per hour. Okay, and let's go back and reread again. So it said at noon, obviously that has to do with time. A train 1 leaves Bridgeton heading east at 90 miles per hour to Cogsville, which is 450 miles away. By the way, let me go ahead and do that. Distance is 450. That's a total distance. So watch where I'm putting it in my chart. Not in the boxes, but below the distance column. Okay, that's the total distance. All right, whenever they give you a situation where one leaves before the other or the other one leaves after the other, I would always ask myself the same question. Which train, in this case, traveled for a longer period of time? Because you guys do much better with plus signs than you do with minus signs. Okay, so do you guys agree? If train 1 left at noon, but train 2 didn't leave until 12:15, that means train 1 traveled for a longer period of time. So I'm going to call train 2's time X, and then train 1, since it traveled for a longer period of time, it's going to be X plus the 15 minutes. But I can't write X plus 15 because that would imply X hours plus 15 hours, and we don't mean that. But the time is in hours because look at our rate, it's in miles per hour. And so instead of writing 15, which would imply 15 hours, I mean 15 minutes. And isn't that 15 minutes out of 60 minutes that are in an hour. So if I simplify 15 over 60, do you see where I'm working down here, bottom left of my screen? That simplifies to 1/4, and isn't that exactly what 15 minutes is 1/4 of an hour. So that's what you need to write right there. Okay, so not only was this problem a little tricky because of the difference in time, but you had to know to write 15 minutes as 1/4 of an hour. Okay, so now that I have my two boxes, I can multiply straight across. Do you see once you get the concept of getting organized in these charts, then writing everything out just kind of falls into place. It's so easy. Okay, my equation becomes 90. I'm going to go ahead and start distributing because I'm running out of room here. So 90x plus, let's see, 45 halves. You know what? I'm just going to write that as a decimal. That's 22.5 plus 100x equals 450. All right, so I have 190x when I combine those terms, and then my 450 minus 22.5 is 427.5, and then I divide that by 190, and I get x equals 2.25, and when I look back at my chart, oh, that's right, x is how much time train 2 took. Well, that 0.25 is 1/4 as a fraction, right? And so that means 15 minutes. So 2.25 hours means 2 hours and 15 minutes. Now their question was, and you always want to do this, go back and read what the actual question was that they're asking. It doesn't say how long will it take. It says at what time will they pass each other. Okay, since this 2.5, here, let me box it in red. Since this 2.25 for my x, when I look at my chart, x was how much time it took train 2, then I'm going to come over here to my picture at train 2, and I'm going to add 2 hours and 15 minutes to that 12:15 departure time. Okay, so that gives me 14 hours, 30 minutes. That's like military time. We don't usually use military time, so I'm going to subtract 12, and this makes it 2:30 p.m. And you do need to say the p.m. Okay, and that is your final answer. Now, if you wanted to, you could take your 2.25, come up here, let me circle this in green, come up to how long it took train 1 to travel that distance, and it's 2.25 plus another 0.25, so that time, total time, would be 2 hours and 30 minutes, or 2.5 hours. So if you add to this noon, which is 12 p.m., 2 hours and 30 minutes, you are also going to get 14:30, which when you subtract 12 is 2:30 p.m. So you can see you get the exact same answer. So it just depends if you want to add the total time that they spent to the train 1 departure time or to the train 2 departure time. It was actually easier to do train 2 because then you didn't have to go back and add 15 minutes to the X time. Okay, I hope that made sense to you. All right, let's see. That was 14 on the worksheet for Emma. All right, Sarah is asking for page 111, number 28. You know what, Sarah, I'm going to hold off on your questions. You have asked a lot of questions, and I actually appreciate that because not a lot of other people are asking questions. But let's answer some other people's questions first, and then I'll come back to yours, okay? All right, so let's see. Elaine is asking for number 16 on the worksheet. Okay, so worksheet number 16, and I think I'm going to draw a picture for this too. Actually, I don't think you guys need it. Do you understand the concept that if somebody goes upstream and then they turn around and come back downstream, the exact same path, that their distances are going to be equal? So when I write rate times time equals distance, okay, it's going to seem like they didn't tell you a total down here, like, wait, they didn't tell me what the total is. And that's because if you go upstream and then turn around and come back downstream, these two distances are going to be equal to each other. Does that make sense? So you don't need to know a total distance. The distances are equal to each other. Okay, so let's read this. It says Daniel drove his boat upstream on the Yay Math River in 5.5 hours. So upstream, 5.5 hours. And then made the return trip downstream in 4.5 hours. It says the current is 2 miles per hour. How fast is his boat traveling in still water? Okay, so you understand when you're going up or downstream, the current is either going to be slowing you down or making you go faster. In all of these problems that have this situation, whether it's current hindering or speeding up a swimmer or a boat, or if you're a plane and then the wind is either hindering you or speeding you up, you always want to start with the main part, the main thing. So the swimmer is the main thing, and then the current helps or hinders. The boat is the main thing, and then the current helps or hinders. The plane is the main thing, and then the wind either helps or hinders. Okay, so the boat, in this case, is the thing they're asking us to solve for. So I'm going to call that B. So you start with B. The boat is the main thing. And now the current that they told me is 2 miles per hour. Let me start with going downstream first. When you go downstream, the current is going to help push you along, and so you're going to go even faster. So downstream is going to be B plus 2. But then upstream, now the current is hindering you. It's going to slow you down, so it's B minus 2. Do you understand that? Now, if you put 2 minus B and 2 plus B, you're going to get the whole thing wrong. So you've got to understand, you start with the main thing. The boat is the main thing. And then the current helps or hinders. Okay, so this distance is going to be 5.5, the quantity B minus 2. And by the way, you can call that BX if you'd like. I just think using letters that make it make sense kind of makes it make more sense. So B for boat. Okay, and then we already talked about this. When you go upstream, let me draw a little picture. If I start down here and go upstream, but then I go, oh, I have to go back home. So I turn around and I go back downstream. Can you see that your distances are the same? Okay, so 5.5, the quantity B minus 2 is equal to 4.5, the quantity B plus 2. All right, so when I distribute, I get 5.5B minus 11 equals 4.5B plus 9. I'm going to subtract 4.5B from both sides, so I get 1B, and then I add 11, and I get 20, and there you go. The speed of my boat is 20, and I look at the units, and it was miles per hour. And there you go. Okay, now can you check this? Absolutely, you can check this. Don't do it with the equation, do it with the words. Actually, the chart's going to kind of help me. Okay, if the boat all alone, like in just still water, if it was on a lake, can go 20 miles per hour, then against the current, it would be 18 right here. That's my B minus 2. And then with the current, it would be 22 miles per hour, right? With the current helping it. So I'm just going to take my calculator and figure out what's the distance. Well, if I go 18 miles per hour against the current for 5.5 hours, I'm multiplying those, my distance ends up being 99 miles. Now, so far, I have no idea if that's right or not, but now I'm going to do the second one, 22 miles per hour times 4.5 hours, and look at that. That's also 99. So because those are equal, I know my answer is correct. Okay, you guys should be checking every single problem. When you guys take the test on Friday, don't you dare turn in your test. If there's extra time, go back and double check all of these, okay? I would probably double check as I go, but for sure at the end, if you have extra time, go back and double check. Okay, Elaine, I hope that was helpful. All right, Gianni is asking for number 13 and 15 on the worksheet. Okay, let's go purple. All right, worksheet number 13. All right, Larry has an annual return of $213 from $3,000 invested at simple interest, some at 5% and the rest at 8%. So the fact that they said some here and some there means we're taking this pile of money, $3,000, and we're going to split it up. Okay, not in half. They didn't tell us that. Okay, I'm going to write my pretty equation, principal times rate times time equals interest. Okay, see why I'm saying it's pretty? That should help you remember that equation. Okay, by the way, all the equations that you write at the top of your chart, none of those will be given to you on the test. You need to be able to come up with those. All right, so let me go back. Larry has an annual return. That's his interest return. So it's a total that they just told me, and it's $213. So I'm putting that at the bottom of my interest column. Okay, then it says he invests $3,000, but some of it at 5%. Let me go ahead and put in the rates. So 0.05, not 0.5. You're going to get the whole thing wrong if you put 0.5. 0.5 would be equivalent to 50%. Well, it's only 5%, so 0.05, and then the rest is at 8%, so that's 0.08. You always put the decimal equivalent of percents. Okay, so the total amount of principal Larry's investing is $3,000, but we need to put the individual principals. How much at 5%? How much at 8%? I don't know either one, but you cannot call them both X. You can only call one of them X. By the way, D. I don't know if you just typed something, it looked like it. Oh, I will answer your question, D, if you log out, log back in, and put your correct name. Okay, I'm not answering somebody, I don't know what your name is. Okay, so back to this. If you guys can picture a pile of money, okay, here's my pile of $3,000. Pretend they're $3,000 bills, okay? And I tell you, hey, I'm going to take part of that money, part of it, let's take X of it, and I'm going to go put that in this account that earns 5% interest, okay? And now I want to know how much is left, okay? So listen to the way I'm going to say these words. I started out with $3,000 and I just took away X dollars. Okay, well, when you guys started learning how to subtract in elementary school, you probably said something like 3,000, take away X. Well, that's exactly how much money is left over. It's 3,000, take away X. 3,000 minus X. So let's add those two boxes, the X plus the 3,000 minus X. When you add those, don't your X's cancel out, and you get a total of 3,000. Okay, so when you start out with 3,000 and take away X, what you're left with is 3,000 minus X. It is not okay to say X minus 3,000. That is completely wrong. Okay, so because they talk about annual interest, my T is 1. And now that I have my 3 boxes, I can multiply straight across to get the fourth. So 0.05x. And for the next one, 0.08, the quantity 3,000 minus X. I'm just multiplying straight across. And then here is my equation, and I don't even need to think. Okay, so here's my equation, 0.05x plus, I'm going to go ahead and start distributing. So let me use my calculator, I have a real calculator. 0.08 times 3,000 is 240 minus 0.08x equals 213. Okay, so if I take 0.05 and subtract 0.08, the coefficients of x, I get negative 0.03x. And that might bother you that I got a negative, but look at what happens on the other side of the equal sign. When I take 213 and subtract 240, I get negative 27. So of course, when I divide both sides by a negative, my negative 27 divided by negative 0.03, I get positive 900. If you guys get an answer that is negative, something is wrong. Don't just erase the negative and go, I'll just hope that it's supposed to be the opposite of that. You probably did something wrong. I'll just make up some things that I see students do wrong all the time. Instead of putting 0.05 for the rate for 5%, they'll put 0.5. Well, that will mess everything up. I don't know that that gives you a negative answer, but that's a typical thing that you guys will make some little careless mistake up there, but when you get a negative answer, that's telling you you've done something wrong. So listen to that. Okay, this x equals 900. I'm going to come back over here. That's $900 at 5%. And then when I plug that in to the second box below that, 3,000 minus 900, That's $2,100 at 8%. Now, I don't know for sure that that's right. I'm feeling pretty good about it, but I can double check it. So I'm going to take $900, multiply it by 0.05, and that gives me $45 in interest. When I take 2,100 and multiply it by 0.08, I get $168 in interest. So now I'm going to add 45 to the 168, and look at that. I get $213, and now I know I'm right. Okay? All right. So D, did you know I was going to tell you what principal means, but only if you change your name? Okay, let me know if you're going to do that. Okay, moving on to other questions. Let's see. That was Gianna's question, and there was another one. Yeah, 15 on the worksheet. Okay, worksheet number 15. All right, let's see. A financial planner wants to invest $8,000, some in stocks, earning $15 and 15% annually, and the rest in bonds, earning 6% annually. All right, so it's another investment problem. So that means we have a pretty equation on top. P times R times T equals I. All right, so principal, let's write in the rates. So let's see, stocks, I'm going to put an S for stocks and a B for bonds. Stocks were 15%, 0.15, and then bonds are 6%. I bet you somebody put 0.6, but no, it's 0.06. And then because they said annually, I know my T's are going to be 1. Okay, so the $8,000, that's a total because they said some at this percent, 15%, and the remaining at 6%. So you guys, that's the exact same picture that I was trying to show you earlier. If you have a pile of $8,000 and I tell you, hey, let's take X and invest it at 15%. So I'm putting my X right there for principal at 15%. Then what's remaining? Well, I started out with 8,000 and then I just took away X. So 8,000 take away X is 8,000 minus X. And that's my principal for the 6%. And by the way, it doesn't matter which one you call X, the other one will be 8,000 minus X, no matter which one you called X. All right, when I add those two boxes, the X's cancel and I get a total of 8,000. So that's how it works. Okay, so I have my 3 boxes. I'm going to multiply straight across to get my interest. And so 0.15x, and then here 0.06, the quantity 8,000 minus X. And I haven't written down how much interest they said we got. How much should be invested at each rate to get a return of $930 annually from the 2 investments. All right, so my equation is, I'm going to switch to black. 0.15x plus 0.06, the quantity 8,000 minus X equals 930. All right, so distributing, use our calculator to not make any careless mistakes. 8,000 times 0.06 equals 480 minus 0.06x equals 930. Please don't try to say, I know how to do 0.15 minus 0.06. I just see so many mistakes with decimals like that. For instance, somebody will go, I know 15 minus 6 is 9, and they'll write 0.9x. Well, you just messed up the entire problem because it's not 0.9x, it's 0.09x. Okay, and then my 930 minus 480 is 450. So then I divide by 0.09, and X equals 5,000. Okay, so I'm going to go back up to my chart, and having that so well labeled, I know $5,000 is in stocks, or you know what, I'm actually going to say $5,000 at 15%, or you can say stocks, whichever one. And then when I plug in the 5,000 for X down here, I get $3,000 at 6%. It's a little messy, sorry. And there are my two answers. Can I check this? Of course I can check this. I can figure out how much interest they earned. So $5,000 times 0.15 gives me $750 in interest. And then the $3,000 investment at 6%, that gives me $180. And then I add those together, and look at that, I get $930. That tells me my answer is correct. Okay, that's all it takes. Doesn't really take very long, does it? Okay, we have about 15 minutes left. Okay. All right, yes, let's do the digits problem from the quiz. I think that's probably, for most people, the hardest type of word problems. All right, so quiz number, find which one it is, number 7. Okay, there's more than one way about going about a digit problem. This is the way I do it. All right, so I'm going to write my 2 lines, and I'm going to use T for tens and U for units. Okay, now I know on the quiz they talked about the ones digit. If you use the letter O for ones, I understand why you're doing that, but your O's sure look like zeros, and so I think you're setting yourself up for making mistakes, accidentally thinking you have a 0 when really it's supposed to be the variable O. So instead of calling it the ones digit, I call it the units digit, and I use the letter U. Okay, when they talk about a number, okay, whether it's the new number or the original number, when they say the number, they mean the value of the number. Okay, so let me go to the next page for a second and talk about value of a number. If I have the number 53, if you add 5 plus 3, you get 8. Do you agree 8 is not the value of the number 53? This would be called the sum of the digits. Okay, they like to do that. Tell us what the sum of the digits are. Sum is. So the sum of the digits of my number 53 is 8. Okay, but that has nothing to do with the value of the number. The value of the number 53 is not 5 plus 3, it's 50 plus 3, right? That's what gives you the value of 53. So how can you get 50 out of the number 5? Well, don't you multiply it by 10, and then you add 3. So 50 plus 3 gives you the value of 53. Well, no kidding, we multiply 5 times 10. It's in the tens place. That's the place value, right? Okay, so now let me go back to this. If my tens digit is being represented by the variable t, then the value of this 2-digit number is 10 times t and then plus u. Okay, I'm going to call this in red my original number. Okay, I'm calling t then u my original number. But now they say, let's make a new number. We're going to reverse the digits. They love to do this. Okay, so if I reverse my tens digit and my units digit, then the u goes here and the t goes there. So you should be able to say what the value is now of my new number. Let me kind of separate this. The value of my new number is 10 times u plus t. Okay, do you guys follow that? All right, now I'm going to read these words kind of a few at a time and write my equations as I go. All right, so first it says, in a 2-digit number, right now we're talking about the original number, the ones digit that I call the units digit is, well, the word is in math means equals. So I'm going to write u equals, the units digit is, 1 more than, when they say either 1 more than or 1 less than, I want you to go to the very right and write the plus 1 or the minus 1. So 1 more than, twice the tens digit, 2 times t. So look at just from left to right, u equals 2t plus 1. It's the units digit is 1 more than twice the tens digit. Okay, so there's one equation, but it has a u and a t in it. So I can't solve one equation for 2 variables. So that's why there's another equation coming. It says when the digits are reversed, the new number is. So this is imperative you understand this. When they say the new number is, they mean the value of the new number is. Okay, so I'm going to write 10 u plus t, that's the value of the new number, is my equal sign, 1 less than. So watch what I'm doing. I go to the very right and I write minus 1. That's how you write 1 less than. You subtract 1 from something. And it says 1 less than twice the original number. So 2 is the twice times. And then my original number, let's go up here, means the value of that original number. So in the parentheses goes 10t plus u. And there are my two equations. Okay, the second equation is a little complicated, so I'm going to simplify it. So it's 10u plus t equals, I'm going to distribute my 2. So I get 20t plus 2u minus 1. Let's get the u's together. So if I subtract 2u, I get 8u. I'm going to subtract 1t, that gives me 19t, and then I still have my minus 1. So here's my simplified equation after I distributed and combined like terms. Now, back to this first equation up here, since the u is all alone, I'm going to take this expression, 2t plus 1, and I'm going to substitute it into this second equation where the u is. Okay, so I'm going to get 8 times, and then instead of the u, I write 2t plus 1, and that equals 19t minus 1. So let me distribute. 16t plus 8 equals 19t minus 1. Let me come up here. I'm going to subtract 16t from both sides, so I get a 3t on the right side of the equal sign. Then I'm going to add 1 to both sides. I get 9 on the left side, and when I divide both sides by 3, we get t equals 3. Okay, so using pretty blue, I'm going to come up here and say if my t is 3, then my u, I'm going to plug it into this equation right here. I'm going to plug in that 3 for t. So 2 times 3 is 6, plus 1 is 7. So I think my original number is 37. Okay, but I'm going to check it. So let's read all these statements they said. In a, what number is this? Quiz number 7. Okay, I was looking at the worksheet. In a 2-digit number, the ones digit is 1 more than twice the tens digit. Well, let's look at the number 37 here in blue. If I take that tens digit, 3, and double it, twice the tens digit, I get 6. Isn't 7 1 more than 6? Okay, so far so good. Then it says when the digits are reversed, the new number is. Well, my new number would be 73, right? If I reverse the 3 and the 7, I get 73. It says that new number should be 1 less than twice the original number. Well, if I double 37, I get 74. And isn't 73 1 less than twice 37? Yes, it is. And so my final answer is 37 because they said find the original number. Okay, so 37 is my final answer. See how I'm checking it with the words, not with equations. Okay, all right. There you go. That was for Gianna. You're welcome. Okay, let's see. We have about 6 minutes left. Okay, I'm back to some of Sarah's questions. So let me see where I dropped off, stopped. Okay, I haven't done anything from the book yet. So let me look at page 111, numbers 28 and 30. Okay, I think actually I like 28 because it talks about the difference in time that I know is tricky for you guys. Okay, so this is actually on page 112, number 28. It refers back to number 27, but I'll read 27 as I do this. Okay, so it says, suppose Dan and Fran live 450 kilometers apart and they begin driving toward each other. Okay, so I'm going to put Dan right here, Fran over here. They live 450 kilometers apart. Oops, kilometers. That's a distance, right? Okay, so then it says Dan traveling an average rate of 50 kilometers per hour. So here's Dan going towards Fran. Okay, he drives 50 kilometers per hour. And then Fran is driving towards Dan, and she's traveling at 55 kilometers per hour. Okay, so now in number 28, they say, suppose that Dan leaves at 12 noon. Okay, so over here, I'm going to put 12 noon, and Fran leaves at 1 p.m. Okay, this is obviously a distance problem, so I'm going to make my chart. The equation that goes up at the top is rate times time equals distance. Rate times time equals distance. I'm going to put D for Dan, F for Fran. We know Dan is going 50 kilometers per hour. Fran is 55. And now let's talk about time. I'm going to say the exact same thing I did on the previous problem where we had a difference in time. They did not start at the same time. Dan started at 12 noon and Fran started an hour later at 1 p.m. So ask yourself the same question I suggested you ask before. Who drove for longer? Didn't Dan drive for a whole hour first before Fran ever started? So didn't Dan drive for longer? He drove for 1 hour longer. So I'm going to call Fran's time X, and then Dan's time is X plus 1. Remember, time is in hours, and that is exactly 1 hour more. Okay, so once I have my two boxes, easy to find the third, just multiply. So 50, the quantity, X plus 1. Fran's distance, 55X. And they told us the total distance between their two houses is 450 kilometers. So my equation is 50, the quantity, X plus 1, plus 55X equals 450. So when I distribute, I get 50X plus 50 plus 55X equals 450. My X's add up to 105X equals 500. And I just divide both sides by 105. 500 divided by 105. And I think I'm going to simplify that. Okay, I get 4. What number is this? 28. Yeah, I don't have the answers here. I get 4 and 16 over 21. And this is in hours. Okay, if I change that to an approximation of hours and minutes, of course it's 4 full hours. So let me subtract 4 from this and just have that fraction. I'm going to multiply that by 60 to change it. Oh, yeah, I need to go 16 divided by 21 times 60 minutes, and I get approximately 46 minutes. So, whoops. I accidentally changed the size of this box. Okay, there we go. Here is my approximate answer. Here is my exact answer. I know it's a little hard to read. 4 and 16 over 21 hours, and that's approximately 4 hours, 46 minutes. My sixes are pretty bad. Okay. All right. I hope that was helpful. Oh, it's 400, not 500. Where is there a 500? Oh, yeah. I added I added 50. That's why the numbers didn't make so much sense. I don't know that 400 is going to be better because we're still dividing by 105. Thank you. Even though you still left your D. I don't like that, but thank you for the correction. All right, so when I added my 50x plus 55x and got 105x, I must not have said my words because usually I talk to myself and I say, I'm subtracting 50, and I accidentally put 500 instead of 400. So let me go back and take 400, divide it by 105. Okay, we get approximately, let me change colors here, red. This is all wrong. Sorry about that. 400 is correct right here. So when I divide those, I get that x is approximately 3.8. I'm going to write that. Let me subtract my 3 and change that to a fraction. It's 3 and 17 over 21. So it's not any prettier, it's not a prettier number, but it is correct. So 3 and 17 over 21 hours. If I take that 17 divided by 21 and multiply it by 60 to change this to minutes, hours and minutes, it's approximately 3 hours and 49 minutes. Okay, so either way. Okay, the 3 and 17 over 21, that is exact. The 3 hours, 49 minutes, that's an approximation. Okay, all right. Thank you, D, whoever you are. All right, let's see. It is 8:31. I think I'm going to stop right there. All right, I hope that was helpful. We did, a nice mixture, no pun intended, mixture of problems. And I hope that was helpful. So I hope you will retake your quiz tomorrow. You should do that. And practice, practice, practice. All right, good luck on your test Friday. See you guys later. Bye-bye.